In my last video, I will discuss the different types of bonding, ionic bond and covalent bonds. Okay, and already we know every atom take part in a bond formation or chemical reaction in order to attain 8 electron configuration in its outermost shell. Yes, this is called Octet rule. Okay, then we have discussed the implication of Octet rule, which states that atoms of same or different elements take part in chemical reaction to complete their octet either by transference or by sharing of electrons. The octet rule can be applied to large number of covalent molecule, particularly those of organic nature. However, there are certain exceptions to the octet rule. Okay, students, today I am going to discuss the next very important topic from this chapter, limitations of octet rule. First limitation. Please listen. Octet rule is not required to explain formation of H2 hydrogen molecule and its compounds, the compound formed by hydrogen. Yes, that is the first limitation is hydrogen has only 2 electrons in H2 and its compounds. Please listen. Yes, hydrogen, its atomic number is 1. Yes, that means what? Hydrogen atom has only 1 electron in K shell. K shell can accommodate maximum of 2 electrons. K shell can accommodate maximum of 2 electrons. Thus, hydrogen needs only 1 more electron. 1 more electron to fill K shell, and hence here the octet rule is not obeyed. Thus octet rule is not obeyed in the case of H2 and the compounds of hydrogen H2. Yes, first example H2. Hydrogen atom has only 1 electron in K shell. K shell can accommodate maximum of 2 electrons. Hence each hydrogen atom requires 1 more electron to complete to fill K shell. Then hydrogen shares its 1 electron. This hydrogen atom shares its 1 electron with the 1 electron of the second hydrogen. Yes, that means 1 pair of electron shared between 2 hydrogen atom. 1 pair of electron shared between 2 hydrogen atom. That means in the case of H2, hydrogen atom has 2 electron. Okay, in H2, each hydrogen atom has 2 electrons. Hence, here octet rule is not obeyed. And the second example, the compound formed by hydrogen, HCl, hydrogen chloride. Yes, hydrogen atom has 1 electron in K shell. Chlorine atom has 7 valence electrons. We know the atomic number of chlorine is 17. Its electronic configuration is 2, 8, 7. Okay, that means chlorine atom requires one more electron to complete octet. Then this chlorine atom shares its one electron with one electron of hydrogen. Okay, then now the chlorine atom acquires octet configuration 2, 2, plus 2, 4, plus 2, 6, plus 2, 8. But hydrogen atom has only 2 electrons in its valence shell, outermost shell. Hence, in the case of HCl also, octet rule is not obeyed. Then that is the first exception. Octet rule is not required to explain formation of H2 and its compounds. Yes. Let us discuss the first example for the electron deficient species. Okay, BeCl2, beryllium chloride. Okay, we know in BeCl2, beryllium is the central atom. The atomic number of beryllium is 4. Its electronic configuration is 2, 2. That means what? Beryllium has 2 electrons in its valence shell. Then beryllium combines with 2 chlorine atom. Each chlorine atom has 7 electrons in its valence shell, and we know yes, chlorine atom requires one more electron to complete octet. Then the chlorine atom shares its one electron with one electron of beryllium. Each chlorine atom shares its one electron with one electron of beryllium. One electron of beryllium. Okay, then now here the beryllium has 2 plus 2, 4 electrons in its valence shell. In BeCl2, beryllium has only 4 electrons in its valence shell. That means less than 8 electron. Less than 8 electron. Hence, the BeCl2 is an electron deficient species. The next example, BF3, boron trifluoride. In BF3, the central atom is boron. The central atom is boron. The atomic number of boron is 5. Its electronic configuration is 2, 3. Boron has 3 electrons in its valence shell. Then this boron combines with 3 fluorine atom by sharing its 1 electron. Okay, yes. Then in BF3, the central boron atom has 6 electrons. In BF3, the central boron atom has only 6 electrons in its valence shell. That means what? Yes, less than 8 electrons in its valence shell. Okay. Then the octet rule, we can say that the octet rule failed to explain the formation of molecules like BeCl2, BF3, etc., in which the central atom has less than 8 electrons in the valence shell. In the case of BeCl2, beryllium atom has 2 plus 2, 4 electrons in its valence shell. In BF3, the central atom boron has 6 electrons in its valence shell. Okay, then let us discuss the third limitation. Expanded octet. Formation of a super octet molecule. Yes, super octet means what? In the case of super octet molecule, the central atom has more than 8 electrons in its valence shell. Okay? Yes. We can consider the 2 important examples. First one is PCl5, phosphorus pentachloride. PCl5 central atom is phosphorus. Okay? The atomic number of phosphorus is 15. Its electronic configuration is 285. That means what? Phosphorus has 1, 2, 3, 4, 5 electrons in its valence shell. Then phosphorus, okay, when phosphorus combines with 5 chlorine atom, the 5 electrons of phosphorus mutually shared with, okay, 5 mutually shared with the chlorine atom. That means each chlorine atom requires one more electron to complete octet. Then chlorine atom shares its one electron with one electron of the phosphorus like this. Then in PCl5 the central atom phosphorus has 1, 2, 3, 4, 5 pairs. 5 pairs of electron in its valence shell. That means what? 10 electrons. 10 electrons in its valence shell. In PCl5, the central atom phosphorus has 10 electrons in its valence shell. That means more than 8 electrons. Then PCl5 is a super octet molecule. Super octet molecule. Okay? Yes. Then the second example. SF6. Sulfur hexafluoride. The central atom is sulfur. The atomic number of sulfur is 16. Its electronic configuration is 2, 8. Atomic number 16, 2, 8, 6. Sulfur atom has 1, 2, 3, 4, 5, 6 electrons in its valence shell. Then sulfur, okay, share these electrons with 6 fluorine atoms. 6 fluorine atoms. Okay. That means in SF6 the central sulfur atom has 12 electrons in its valence shell. 1, 2, 3, 4, 5, 6. 6 pairs means 6 into 2. 12 electrons in its valence shell. Then we can say that octet rule failed to explain the formation of molecules like PCl5, SF6, etc., in which central atom has more than 8 electrons in its valence shell. And the last important limitation of octet rule, please listen, compounds of inert gas. We know helium, neon, argon, krypton, xenon and radon are noble gases or inert gases. These are chemically inert. These are already stable. Then according to the octet rule, you can say that according to the octet rule, noble gases are chemically inert. Noble gases do not take part in chemical reactions. But modern findings prove that noble gases like xenon, Xe, and krypton, Kr, combine with oxygen and fluorine atoms to form large number of compounds such as XeF2, xenon fluoride, XeO3, etc. XeO3, etc. Yes, that means what? Noble gases, some of the noble gases also take part in chemical reaction. This is the fourth important limitation of octet rule. Okay? Okay, students? In my next video, I will discuss the next important concept from this chapter, that is bond parameters. Okay, goodbye. Study well.